Welcome to the Inspiring Tech Leaders podcast with me, Dave Roberts. I recently had the pleasure to catch up with the Stantec digital team in the Netherlands to talk about how they're using technology to provide instant insights into soil quality. Many thanks again to Stantec for allowing me to share this insightful podcast with the Inspiring Tech Leaders audience. I hope you enjoy this episode. I'm Dave Roberts, and on today's episode we feature Arthur Coevert and Christiaan, who are part of our environmental services team in the Netherlands. Arthur is a physical geographer with a career spanning 20 years within engineering companies. He is now an account manager for our utility sector clients and joins us from our Stantec office in Arnhem. Christiaan is a GIS specialist with a background in earth sciences and has been with Stantec for 8 years. He is the product manager for the Soil Risk Map platform, helping to guide the software development initiatives and functional integrations. Christiaan is joining us from our Stantec office in Delft. The focus for discussion in this episode is to understand more about how Stantec is using technology to help utility and construction companies gain the necessary information about soil quality needed to support the maintenance and installation of lines and cables into the ground. Welcome to the podcast, Arthur and Christiaan.
Thank you, Dave. Nice to be here.
Yeah, thanks, Dave. Thanks for having us.
Great. So let's start off with you, Christiaan. It'd be good to understand more about the problem that we're actually trying to solve for clients with the soil risk map. Can you tell us a little bit more about that, please?
Yeah, to understand that a bit more, you need to be aware of the situation, of course, here in the Netherlands. And first of all, especially for people outside of the Netherlands, you have to understand most of our cables and pipelines we put underground. And before clients of us, if you want to excavate in the ground, you need to know exactly what the soil quality is to ensure safe working conditions for workers who work there on a daily basis. Because you might be unaware, but the Dutch soil is pretty contaminated. And that could have, of course, impact on your health conditions in a long term. Well, in the Netherlands, we have legislation for this. So you are prohibited to dig in polluted soil without permissions. And besides working conditions and your health insurance, it is also prohibited by law to make soil more polluted than the existing state. You are also prohibited to mix soil, polluted layers with less polluted layers. So that is a bit of a background. That's why we step into this problem. Because as you are going to excavate in the soil, you must be made aware of all these conditions.
That's fascinating. Arthur, how did we actually get started with this type of work?
Well, I and some other colleagues already worked for some utility companies and their contractors. I think since 2004, 2005. And they were mainly the utility companies dealing with gas, electricity, and water. So I had some contacts. At that time, our work was, call it reactive. They contacted us. They said, we have to do an excavation over there or over there. Can you please tell me what soil quality is, if we can do the excavation safely, or we have to do something because of legislation. At that time, so that's 17 years ago, I'm getting old, I guess, it took us per project about 22 days. So it was doable, and there weren't many. So, they knew it took about 3 weeks before they had the correct answer. Then, and I think a couple of years later, soil quality and pollution became more relevant because there was more specific legislation, and most important, there was also more enforcement. So the companies had to do something, and this resulted eventually in 2012, 2013. Then Vodafone Ziggo called me. That's, by the way, the mother company is Liberty Global. Called me after they had an incident. He said, well, we have a problem. Arthur, can you come over here? We have to do something. I said, well, next Monday you will be the first. And I went there, and they said to me, well, we want to be compliant. We have 25,000 excavations each year. Please help us. And at that moment, we realized that reactive handling was not an issue anymore. We had to do something. So that was the first then the first steps were made to create the soil risk map, because we knew we had to gather the information proactively.
So Arthur, why was Stantec so well positioned to develop this type of tool to begin with?
Well, to be honest, I think technically we were not special equipped or superior next to others. I think because of when they had the issue, we acted directly. So because of our handling and our thinking with the client, and also thinking out of the box, we created trust. They trusted us. And also at that time, our vision was we don't want to do unnecessary soil investigations, especially if you know that you have already a lot of information in this country about the soil quality. So that's really different from other engineering companies who have a business model of doing the soil investigations. We said, no, that's not what we want. Please let us gather the information, the soil information, and maybe most of the times we can already give you an answer without going out in the field and gather the extra soil information. So I don't think for your answer, we were not specially equipped, but it was account management. They trusted us, and together we developed in the years after the soil risk map.
What a fascinating journey it's been so far then. So Christiaan, if I come to you, so how does it actually work technically? What does the soil risk map tool look like under the covers?
So started out with just a simple SharePoint environment, which is nothing compared to what we have nowadays. Nowadays, it is a online browser application, a GIS browser application, where we handle short distance projects. So if you have an area or a project for instance, 2 kilometers, you want to excavate in the soil, you can just draw it in an online application where you see a map, you see where you want, you can search on your area, you can draw it, and then immediately the application itself provides you with an answer about safety conditions, about legislation, about which information about chemical soil quality is there available. If you want, you can get instantly a report out of it. And of course, as is always with this kind of big data tool, if the data is insufficient, you can request a research at Stantec with just the click of a button. All the information flows back to our clients through this application. And so the map itself is also self-enriching. In those situations where the data is insufficient, we do a research, fill it in the application, and so the answer is there for maybe the next time someone else has to excavate on that same location. And the base for these apps, of course, is the data, big data, soil data. Without the data itself, it is just a blank map. So we gather soil data at dozens of authorities, provinces, municipalities here in the Netherlands. We process all those delivered databases, and we ourselves enrich it with some more information. We test it against certain safety condition parameters, and then we serve it in our internal but also external applications and tools. We serve our data through so-called APIs in software of external systems. So we are still full in control about what the data is exactly and how you should use it. But users have the freedom to say, okay, I have my own tool, I want to have it served in there, or I don't have anything, let me please use your online JS browser application.
Well, that's a really exciting evolution of the tool over the years and how it's developed. That's fantastic. So why do you think it's worked so well in the Netherlands?
Well, that is for several reasons, and a couple of them are already mentioned by Arthur. Of course, there is legislation, and legislation, if you want to work compliant as a organization, you have to fulfill on those needs. And of course, this legislation was already in the past as well, but enforcement was lacking. And that has changed also over the years. So when you have legislation and it is enforced, then the need to be compliant becomes, of course, more urgent. That said, the next thing is, of course, you can say, okay, you need to know the chemical soil condition, but how can I know it as a company who's just excavating in the soil? How do I know what the chemical status of the soil? I don't know. Well, luckily here in the Netherlands, over the years means already, I think, maybe go back to the 80s, maybe even 70s, Arthur. You know, you said already you are older.
Yeah, no, not. Yeah, that's true. No, well, digitally we gather the information since the 90s. I think in the 80s it was all on paper, but in the 90s the first soil information systems were developed. Yeah.
Okay, so from that point onwards, but also the data was there already. The reports of the 80s was all filled in this digital system, so-called soil information system. And because we have that in the Netherlands, and that authorities were required to fill in and store their data in this system, we have already a lot of public data available conform a standardized protocol, which we also use as our main data model to process these vast amounts of data for the soil risk map. So coming back to your question, Dave, why it works so well, legislation, the enforcement of it, and that the data is already available on a national scale.
So for the historic data, has that now been digitized?
Very old data is not digitized, but we know there's a lot of data. And I think what's interesting is now that we developed together with another company, we developed an AI, artificial intelligence, who can, if you have a big database with all types of PDFs, it can be a soil report, it can be a letter, it can be anyone. It is a database of a government. The AI picks out the soil reports. Further than that, the AI picks out the location and the AI picks out the chemical analysis. And this way, we, but also the government and our clients, can have an extra insight in what information is available in their archives, because they don't know. They have a big database with all PDFs, but it can be anything. So we are trying to also of the older data transfer it to digital data.
Yeah, and that is really, really, at least for us, but really state of the art, especially if when you have extracted the relevant PDF soil reports. The next thing to convert data out of a PDF table into usable values in a database. So the analytical results of the chemical soil. Yeah, that is really state-of-the-art technology, because it is also needs to be certain, of course. We can make mistakes in dots or commas, or transferring a number 8 into a 0 or whatever. That may have huge consequences.
Yeah, and it is unique as far as we know in the Netherlands, and maybe even further. So because our goal is to have the most information, the best information. We call it to have the highest self-service. So our contractors or our clients can look up the map and make a report, and they don't need our soil advisors, because the data is so good that you already have an answer and we don't have to look at it. That is our main business model. So we do everything. We invest a lot in getting the database better, getting more information, etc. That's good to know.
What type of clients is using the tool, and what are they mainly using it for?
Well, at this moment, the main clients are the utility companies, because they do the most repetitive work, excavations. We call the number of times Ziggo use it is, so Liberty Global, 25,000. After that, UPC came also, so that's 50,000. We have telecom, other companies, local Dutch telecom company. There's also to 15,000. Last year, with all our clients, used it for 99,500 locations. It was used. And from that 99,500 locations, I think about 24,000 locations our advisors were needed. So it's about 57%. And what type of work is it? Well, the utility companies use it for new build, for reconstruction, or malfunction of their pipes, cables. Fiberglass is now very hot, of course. So that's what it's used for, and they use it in several ways. First of all, our information or insight gives a good insight in the soil quality, and it can be used at the first stage, which means they can be used as a risk assessment. If you want to put glass fiber into the ground in a city, you can look, well, is it clean, or is it a bit polluted or heavily polluted, and what are the costs? So it can be for risk assessment, and they use it. That was already at the start. Use it for their design. Where do I put my cable or pipe, and what's the quality? And as Christiaan also mentioned, well, it gives the right information to work safety and to work compliant by the law. So that's what it's used for. Still an answer, Dave?
That's fantastic. So what's next on the roadmap for the soil risk map?
Well, we have developed, I think it was last year, Christiaan, we developed a roadmap.
Yeah, that's correct.
Yeah, and that's a roadmap for the next 2-3 years. So we have several items on it. One of them, for example, well, first of all, we are now talking about soil quality, chemical soil quality. We also developed maps with other data like groundwater levels or archaeological data or unexploded ordnances, explosives, like that. So we want to be the company which provides soil data, so not only chemical soil data and safety, but also more data. So that's one of them. But well, we now use the soil risk map for, I think, 8 years it is now, and we gathered a lot of information, maybe some stats. We used, or the soil risk map has been used altogether now for 500, 600,000 locations, and we did a lot of 25% now. Our investigators fill the information with their own investigations. So we have a lot of data. And with this data, we are trying to do multi-criteria analysis. So what do we see some combinations? And maybe is it not useful to do a soil investigation because we know that from the other 100 locations at a certain, I don't know, village, or I don't know, was always clean. So why investigate it the 101st time? So that's what we are starting up, the multi-criteria or risk analysis. Yeah, maybe also can we be, with the data we have, can we be more predictive? And it's not predictive in kind of the soil quality, but like with the groundwater map, can we predict where some malfunctions will happen for electricity or malfunctions for cables? And do we see this in our data with the malfunction? So maybe we can be predictive. Yeah, and in the end, back to the soil quality, we now have a self-service of 75%. So in 75% of the cases, they don't need our advices. When we started, it was less than 50. I think it was 45% or so, or something like that. Our goal is to make the self-service 95%. So in this way, with the same number of advisors, we can handle a lot more projects than we do now, and we don't need extra personnel. And then I don't have to explain that it will lower the cost for us per project, and it gives a better profit. But that's our main goal.
So it's been a real pleasure talking with you both today and learning a lot more about the soil risk map. And thank you once again for being part of the Stantec.io podcast.
Yeah, thank you, David. It was great to be in a podcast for me for the first time. Thank you very much.
Yeah, Dave, also by me. Nice to be here. If people have questions, they now maybe know how to find us. And thank you very much.
Thank you for listening to the Stantec.io podcast. If you've enjoyed listening, please tune in to future episodes where we'll continue to explore how digital solutions are shaping our world. In the meantime, you can also visit our website at www.stantec.io for further information.
Please remember to subscribe to the podcast and stay tuned for more inspiring tech leaders.